Good evening, everyone. I think it's the last slot of the day, so we're not anticipating a lot of people turning up. I think we have critical mass to begin for today. So I hope you guys are having a good 2 days at the conference. Have you had a nice time these 2 days? Come on, the Hadoop community can do better. Have you had a nice time these 2 days? That's much better. Great. So first of all, thank you so much for turning up so late on the second day, that too right before the party where I'm just keeping you away from it. So thank you so much. We're going to have a quick discussion around Hadoop in the cloud. And I'm Nishant Thakur. I'm a technical product manager for the big data team at Microsoft. My responsibilities include a lot of these customer conversations and then enabling and readying the field to have the right conversations on the big data stack with our customers and partners, right? I've been a consultant for about 5 years, developing solutions in BI and big data before I joined our corp team at Redmond. So yeah, I know a thing or two about implementing those solutions as well. And the topic of the discussion today, of course, is Hadoop in the cloud. For some reason, the topic on your pages would read Hadoop on the cloud, and that's grammatically incorrect, I think. Right. So without much ado, I'm just going to go ahead and dive into the agenda that we have for today. Now, my topic mentioned this. My agenda is pretty clean. We're going to discuss why do we have to do Hadoop on the cloud, or why should we even think about Hadoop on the cloud. And then we're going to think about what are the various options that we have to do Hadoop on the cloud. And then what do these implementations look like, or what do these cluster architectures exactly look like? And then we're going to look at how we go about doing these with a couple of simple architectures. Now, I'm from Microsoft. I understand the Microsoft side of the story well, but I've tried to abstract this talk to a generic cloud talk. I might just refer here and there to some things that we have back on the Microsoft stack, but whatever I discuss today actually holds good for any cloud platform, okay? So let's get started on the first point of the agenda. And before I do, I just want to know how many of us currently have a Hadoop deployment that we have in practice. That's a fair number, expected from a Hadoop community. How many of those hands that were up actually have a cloud deployment today? Wow, that's more than I expected, actually. All right, how many of you are on a public cloud deployment today? All of you. That's perfect. Thank you so much. So that sets the context. I'm going to talk more from drawing the lines from a traditional on-prem Hadoop cluster and taking it back to the cloud Hadoop clusters as well, right? So let's look at what traditional Hadoop clusters look like, right? Now, traditionally, Hadoop's not been one of those workloads that anybody and everybody has come in and picked up and developed an expertise around. There has been a specialized workforce around that space. It's hard to get. People are difficult to hire. They are pretty, they charge a good premium as compared to any other technology. And then it's hard to keep them with the company in the first place, right? Now, what do they do to set up these Hadoop clusters? Essentially, a Hadoop cluster is a bunch of machines with a set of resources, be it compute, memory, or storage. And they bring it all together. They deploy certain open source bits after stabilizing them. And then they put in data into these. Now, what are the challenges in bringing this together? The first, of course, is getting people who are experts in there. Second, even if I need a small Hadoop cluster of, say, 4 nodes, I probably need to go spend $30,000 to $35,000 trying to get the so-called commodity hardware and getting it together in a Hadoop cluster that's actually workable for a small POC that I can do on it, right? Now, what if I need more machines? Of course, Hadoop has that provision. I can go ahead and add more machines. But that means there is overhead in terms of extending your clusters. There is downtime with your clusters. And you have to have a reusable mechanism because you're going to need more nodes on the cluster every now and then to grow your clusters. But then what happens when you have a seasonal workload? Like any retail organization, they would see certain workloads grow in a seasonal capacity, and then after that, they don't have any use of all that infrastructure that they've been able to set up as part of their Hadoop clusters. What happens when I don't need these nodes? Is there an eBay or an Amazon where I can sell these nodes off? I've never heard of it. Have you? Well, we don't. And that's where we're going to talk about the enhancements that cloud brings in. But before that, let's summarize what are the challenges with implementation of Hadoop. Primarily, there are three. It's the upfront hardware cost to get the buy-in from the higher management that this is a spending that we're doing for the future, we need to do this, and then we need to scale up whenever we require to. The second one is about capacity planning. How do I go about doing it? Like, OK, where is that reusable script which I can use to just go ahead and add nodes whenever I need to, whenever the workload grows further? And then the third, I talked about it, the Hadoop expertise, the people sitting in this room, which are so scarce, right? Now, let's take a look at the same cluster in the cloud. Well, how do I go about doing this? There is either an image sitting somewhere in the gallery on any of the public cloud platforms that you're thinking about, or there is a managed Hadoop cluster service on each of those cloud platforms that you can relate to. In a span of seconds or minutes, you will have your clusters up and running, be it a one-node cluster or a thousands of node cluster. Irrespective of that, if your subscriptions to that cloud platform have the right level of credits, as well as your credit cards have the right amount of balance, you can go ahead and spin off any number of nodes on that particular cloud platform. How do I scale? Well, resizing is just sliding your bars, and I'll show you what that looks like as well. You want to scale further? Go ahead and scale. When you don't need them, I don't need these nodes, do I? All right, let's drop them off. The cloud's going to take care of it. I don't need to worry. The cloud's going to manage my cluster. It's going to maintain high availability for my cluster according to the SLAs that I've signed with them. And it's just going to charge me for the clusters or the compute resources that I always use, right? Just summarizing that fact a little further. First, no hardware costs. I don't need to pay anything up front. I just swipe my credit card. Whatever resources I use, I pay by the minute. If I swipe it down in 15 minutes, that's all I pay for. I don't need that upfront investment of $35,000 for my POC cluster, let alone a production-size cluster. Second, I have unlimited scale. Can I go to my manager in any services company today and tell them that, OK, I need a 128-node cluster just to perform some performance tuning for a customer that we delivered a project on? He's going to come back saying, forget it, you gone crazy, right? But when it's on the cloud, I can just go ahead and take it up, say, OK, I need this 128-node cluster when I have my data ready for processing for the next 90 minutes, which will cost me probably a couple of $1,000s. And that's perfectly fine. And that could even go ahead and tune up to 7 days in the week, right? And then you're paying for what you need. You're not paying unnecessarily for any hardware that you possess as part of spinning up Hadoop clusters. Only when you process the data, you spin up the nodes. When your processing of the data is over, you scale down the nodes, and you stop paying for your Hadoop clusters or your Hadoop nodes. And again, it's all deployed in minutes. So right from the time you tell us how many nodes you need, the size of the nodes you need, and click on the Start button, within a span of 12 to 15 minutes, you have right from a one-node cluster to a 1,200 node cluster or anywhere in between. It's all spun up in a span of 15 minutes. The next time you need to scale down the cluster to a 4-node cluster, just go to a slider bar, say, OK, scale it down to 4 nodes. I'm perfectly fine over there. Within a span of a minute, your cluster is again shrunk down to a 4-node cluster. Now, how does that happen is something that we'll talk about further into this particular talk. But even before we get any deeper, I just wanted to talk a little bit about how the cloud and Hadoop are ideally meant for each other. Now, I'm going to talk about a few characteristics of a Hadoop cluster. And I can definitely take any comments or feedback that you have if I've missed any of the characteristics on the slide. The first one that I can think about on Hadoop is distributed storage. Well, HDFS, as we know it. It's basically distributed storage that allows you to go ahead and shard your files, store it in multiple copies for fault tolerance and resiliency, and then keep multiple copies of the file ready and serve from the nearest node. The second is distributed compute. Well, once you've sharded your files, you're actually taking the compute to the storage, and then you're going ahead and making that programming paradigm much more efficient by giving it smaller chunks of the files to process. Third is automated failover. Well, once you've done distributed, you need to have a mechanism where if there is a failure, you get to go ahead and fail over to something that's much more stable over there. Again, Hadoop is definitely meant for hyperscale. So be it starting from terabytes of data, or be it getting into throughputs which are in multiples of whatever we've achieved in enterprise systems until now. We need that scale to be able to do that. And the fifth is it's extensible. It's completely open. It has its ports. It has its APIs. You can extend upon it. You can go ahead and build upon it. You can go ahead and write wrappers on top of it, and then call it your own, right? Now, what happens if I just go ahead and change the topic of the slide to cloud and keep the characteristics the same on the slide? Does that still hold good? Does anybody have objections to any of those characteristics falling on the cloud platform as well? Well, it just puts together as a slate. The cloud platform has a distributed storage. The cloud platform is all based on distributed compute. So whatever resources you have, the cloud is optimized to balance the load across all of those resources. The cloud is designed for automatic failover. So you already have that mechanism built in for your storage as well as for your compute resources. The cloud is definitely hyperscale. Whatever you can think of in terms of a Hadoop cluster, just multiply that 5 million times, and that's the scale that the cloud works in. And it's definitely extendable. If it's a service, it needs to have its REST endpoints. It will have all the connectors to it. It will allow you to write wrappers on top of it. And it will make sure that you can integrate your applications right into whatever you build on the cloud. Now, what happens if I just go ahead and bring that Hadoop cluster on the cloud? Isn't that on those same characteristics multiplied or squared off, if I may say so? So what I'm looking at is the benefit of the Hadoop world that we've been knowing for so long and then taking it up on the cloud to extend all of its characteristics manyfold with Hadoop on the cloud. Now, by now, I hope I've been able to convince you to stay through the entire talk. If you're still not convinced Hadoop is meant for the cloud, feel free to raise your hand and challenge me. That's great. Go ahead. Yeah. A very good question around security. All right. Now, when you're talking about security, how much security do we have from an on-prem cluster, and what are the characteristics that we've not been able to bring towards on the cloud? From a different vertical perspective, the cloud has enhanced to go ahead and get certified in accordance with the industrial certifications. And it has even gone ahead to define certain infrastructure which will allow you to encrypt and secure data on the flow, as well as encrypt and secure data which is in still state. So from a security standpoint as well, as we grow these services, they are evolving to go ahead and include all the capabilities that are coming in from an on-prem standpoint. Okay? As I said, from the vertical compliance standpoint, we already have those certifications coming in. So for example, HIPAA, SOC, all of these industrial verticals compliance are all of these public clouds are coming in with those compliance mechanisms. For example, Azure, it already has all the regular compliance certifications for the healthcare, financial industry, as well as for the manufacturing industries. So you can definitely go ahead and bring all that data up. If it's about sensitive data, there are mechanisms to tackle that, and I'll talk about them coming in. Questions, if you could just get to the microphone so that we can record them as well. Okay? I don't mind taking questions as we go along as well. Getting onto the second point on the agenda then, right? Now, we talked about why we should do Hadoop. Let's try and understand what do we have on Hadoop that we can think about. There are quite a few options that we have to deploy Hadoop on the cloud. The first one, Hadoop on infrastructure as a service, which is essentially just taking up your on-prem clusters and taking it and deploying it on Azure or AWS VMs on the cloud. That means you're hiring infrastructure from any of these public clouds and then deploying it on that hired infrastructure. Now, that should ideally address any concerns that you have about control on the cluster, the deployed versions, the way the individual managed clusters are evolving, as well as security, compliance, and governance, because you have complete rights to go ahead and audit or implement any custom security or compliance mechanisms that you want to. Now, there are certain pros and cons to Hadoop in the infrastructure as a service model as well. One, you have complete control. Second, you have on-demand cluster sizing. So you need more clusters, hire more virtual machines. You don't need those virtual machines, just go ahead and shut them off, and the public cloud will take care of them. You'll not be charged for it. And then from a storage standpoint, you have a choice whether you want to go ahead and use the local storage of the hired virtual machines, or you want to use the cloud storage that any cloud platform offers, right? But from a con standpoint, you need to look at that as well. Why do you want to move to the cloud? First thing is, you want to leverage the high availability capabilities of the cloud. You want to leverage the fault tolerance and resiliency up there as well. In this case, if you're deploying on local storage, you may not be able to do that because you are the administrator of those virtual machines. You've just hired resources. You've not hired services to manage those clusters. So you are taking care of all of that. So there is some amount of administration required. And your clusters, if you're using the local storage on the virtual machines, need to stay active all the time so that your queries can be responded to, right? Now let's take a look at another model for Hadoop in the cloud, and that's Hadoop as PaaS, or Platform as a Service. Now, these are basically managed clusters that any of these cloud platforms offers for you to undertake any business activities that you want to perform. So you just go ahead and click a few buttons, tell how many nodes you need, what's the size of the nodes you need, and where do you want this particular Hadoop cluster deployed. And this managed service will take care of making sure it deploys it in a span of 12 to 15 minutes for you, and it maintains it for you. It will support that particular cluster end to end, be it your custom applications running on it, be it your custom jobs that you perform on that particular cluster, or be it the availability of that cluster as per the SLA that you sign off. Now, again, pros and cons. It's a fully managed SLA-bound service. You don't have to worry about anything. Flexible resizing. There's a slider. You can just go ahead and slide it off to the number of nodes that you want, or increase it to hundreds or thousands of nodes in case you ever need it, as per your business's seasonality. You just pay on use. Charging is by the minute, so the number of minutes that you've used that cluster for processing the data, you're paying just for that. Come in for customization options. Oh, you have a plethora of them. You feel the managed clusters doesn't have the right open source components that you need on that cluster, go ahead, script it out, deploy it for yourself. Caveat there, whatever custom components you deploy, you administer and manage them. And again, it's deployed in minutes. As I said, 15 minutes at max for any size cluster, and you should be up and running. Again, there are some cons. You have to forego certain controls on that cluster. You cannot log in or RDP into the worker nodes. You cannot have access to system-level logs, etc. Although each of these public cloud platforms and their managed clusters, just as I can speak about Azure HD Insight, which is Microsoft's managed Hadoop service, offers you a dashboard where you can manage all of the logs coming in from all of your worker nodes, as well as the head nodes that are monitoring it. Now, that's the second option, probably the most prevalent today and the most used across the industry for anybody who's thinking about cloud Hadoop deployments. Now, more and more, we're seeing another mode of Hadoop on the cloud, which is basically big data as a service. So there are certain software vendors or ISVs or system integrators who are working towards hosting their own multi-tenant Hadoop clusters, and they just lend out that cluster for a certain period of time for you to execute certain jobs. So you just go ahead and submit a job, they execute it on their service, on their hosted Hadoop clusters, and then they give you the result back. They just charge you for the amount of resources your query utilized during that span. Again, certain pros and cons. You abstract it from clusters altogether. You don't need to know what is Hadoop. You just need to know how much data you have and what operations you need to perform on it. Again, it's automated resource alignment. So depending on the workload that you're putting forward, resources or number of nodes in the cluster will be allocated to it. It's easy to use interface and APIs since it's a much richer service, so you have better UX, and then you have much, much more aligned towards your custom applications and certain IDE tools as well. And then you can go ahead and use certain familiar languages because they abstract your job definitions to certain known languages as well. Cons, you don't know what is a Hadoop cluster. If something goes wrong, you will never be able to find out what has gone wrong because there are no logs provided. You cannot get into those clusters. You have no access to any logs, etc. Okay? And certainly, in the current solutions that you have in the market today, they're kind of priced extravagantly, right? Now, I say that from the perspective of all the solutions that I have observed. if you've come across any of those big data as a service solutions which you feel is priced reasonably, I'm more than happy to have a more detailed discussion. Now, when we talk about Hadoop in the cloud, it's not just about deploying Hadoop entirely on the cloud. It's also about having a hybrid architecture. Now, you might still want to have an on-prem presence for all of those security, governance, and encryption-related reasons, and sensitivity and compliance and all of those things. So you still want to have that footprint on-prem to gather all that data as it comes in. But there are scenarios for either dev test, cloud burst, or a backup or archive into the cloud that you might want to go ahead and stick to a hybrid cluster. Now, how do you go about doing that? Well, you just need to have those clusters sitting over here, and then you can use technologies like Falcon to go ahead and port the data back onto the cloud, and then spin it together with a completely on-the-cloud managed cluster like HD Insight, which can combine data from on-prem and on the cloud. Now, currently, we have integration capabilities with the Hortonworks data platform, as well as the analytics platform system appliance that we have as part of the Microsoft stack. Okay? Now, let's get into what differences do Hadoop clusters on-prem and on the cloud have. So traditional Hadoop clusters on-prem would look something like this. Okay, you have a client, you have a master node or a head node, and then you have certain worker nodes, or all of these are nodes where all the tasks perform. If it's an on-prem Hadoop cluster, you're usually looking forward to utilizing the resources on these worker nodes entirely. So the storage is part of the local storage on these worker nodes themselves. Now, let's go ahead and look at a Hadoop cluster in the cloud. Well, it actually doesn't look exactly like this. And I talk from a managed cluster standpoint. The focus of the discussion is going to be that managed cluster because that's the most prevalent type of cluster that we have on the clouds. So when we talk about a managed Hadoop cluster on the cloud, it doesn't actually look like what you're seeing here. It ideally looks something like this. You go ahead and separate the storage to reside in a persistent cloud storage, and then you utilize the resources or the compute resources of all the virtual machines that you spin as part of the cluster. Now, I already see a few eyebrows raising. Hadoop was intended to bring compute to the storage. Why are we going the other way around? Isn't that the question in your minds right now? Well, there are a lot of benefits to that, and we'll show you. But just to address that question, that principle was good when Google wrote the papers in the year 2002, when there was no cloud paradigm, when we did not have the advances that we've had in the last 13 years in the networking field, and when we never heard about a shared blob storage on a public cloud. And I'll dive a little more into the benefits as we move along as well. Now, let's take a look at what a HD Insight cluster architecture would look like. HD Insight, again, as I said, was Hadoop on Azure. That's a managed service that Microsoft offers on its public cloud. Now, this is what a Hadoop cluster would ideally look like, where you have a secure gateway, you have highly available head nodes, which are definitely at least 2, and then you have your worker nodes defined on the number of nodes that you've wanted on your cluster. Now, if you notice, the important factor is that WASB layer under that cluster. That's Windows Azure Storage Blobs, which is the public cloud storage blobs that we offer as part of Azure. And the HD Insight clusters rely entirely on that storage layer. Now, just to give you a little bit of a background on that as well, like This is part of the open source community as well. The drivers to connect your Hadoop clusters to a public cloud storage, be it in Amazon S3 or be it the Azure storage blobs, are all there as part of the Apache Hadoop code itself, the Apache common code set. And you can also go ahead and redirect your on-prem clusters to store the data on the public cloud. Okay? Now, let's come in and address the question of decoupling compute from storage. Now, when you go ahead and do that, you have a number of nodes that exist on your compute clusters. And then there is the storage, which is possessing all the data that you need to process. Questions that arise are, what's the latency? What's the consistency? Is there enough bandwidth? And those were the questions that were tried to be addressed when you brought compute to the storage, because you do not want to worry about these at all. With cloud, you actually don't have to worry about them at all. From a latency standpoint, there is InfiniBand connectivity between the compute clusters and the storage layer. There is a VNet that it resides inside, and that provides you with HDD-like latencies, as if you are just querying and processing the data that resides on the local storage. From a consistency standpoint, cloud ensures SLAs for that. And from a bandwidth standpoint, the Azure flat network architecture would provide you somewhere close to 50 terabytes plus aggregate bandwidth. So you don't need to worry about that in a cloud infrastructure at all. And that's why I said, in 2002, when Google were moving away from it, it actually made sense. In 2015, those questions are not relevant anymore. Now let's go ahead and look at what the benefits of decoupling could be like. And I'm going to talk about these from all the workloads for Hadoop as well. So we're going to talk about it from first the query workload. Well, in the query workload, what you do is execute certain jobs. You go ahead and write certain Hive scripts or Pig scripts, or you have some Mahout algorithms that you're addressing with the help of your workload. And then you're just storing your data in your clusters to be queried upon. Now, if this exists as a decoupled, how do you benefit? First, you just require clusters while processing the data. So the compute clusters that you spin up are only to process the data. When you finish off with the processing, you can tear down your clusters and stop paying for them. Your storage is persistent. It still stores the results. Your BI tools can still go ahead and connect to the results stored in the persistent storage and go ahead and spin up all the various kinds of analysis that you want to do on top of it. Second, you always have cloud storage replicating data on other geographies. Now, how does that help? Well, I could spin up a cluster in West US, but I have a global team. I have a team sitting in Europe. I possibly have a team sitting in Australia. And as long as I can replicate the data across those data centers on the cloud, I can allow them to spin up clusters on the data sitting locally in their data centers so that they can spin up their own Hadoop clusters and spin up their own jobs for their own analysis. Right? Again, once you're done with everything, you just delete those clusters when you're not utilizing them for their compute power, which will bring down your cost considerably in there. Okay? Now that's just from the query workload standpoint. And this holds good for any kind of query workload, be it batch mode processing or interactive querying. Now let's look at it from a NoSQL workload standpoint. When we talk about NoSQL workload on Hadoop, we're essentially talking about HBase. Now, HBase is not a very high compute intensive workload. It is essentially a key value store. You're writing simple queries onto a key value store and getting certain results back from it. If you have it on-prem, you have a large amount of data, because of which, if you have a considerable HBase presence, you have hundreds of nodes of HBase. But you're actually not utilizing even a fraction of the cumulative compute power that you possess as part of those hundreds of nodes. Now, what if I take that to the cloud and I decouple the storage and the compute? My cloud storage can now go ahead and store petabytes of data, any amount of data that's coming in. I can just have a 4-node cluster, or at max, in really good workloads like those with Facebook, a 40-node cluster, which will go ahead and suffice all the queries that are coming in onto my storage. And just because my storage is decoupled, I don't need to worry about bringing in more nodes whenever I get more data. And that's going to bring down the cost of your clusters anywhere between 6x to 20x, depending on the workloads that you bring on HBase. Now, the third workload that we usually see is the streaming workload. Now, in the streaming workload, well, what's happening? There is real-time data coming in. You're storing all of that data. To store historical streams of data, you need storage. But when you look at the amount of compute you're using to process those streams, you're actually not using a fraction of the capacity that you possess as part of your compute workload. Now, what if I decouple it? I bring in the streams, I process them, I go ahead and store them on the Azure Blob. I can go ahead and query them with the help of a query workload, or I can go ahead and store them in an HBase cluster in there, and then go ahead and query them or use BI on top of them as I would, or analyze them with any machine learning models if I so desire to. Now, this should kind of clear off any apprehensions that you may have around what's the trade-off for decoupling the compute from the storage. Now, let me make it clear. It is not that it is exactly the same as it is with on-prem clusters. There is definitely a trade-off. So if you were seeing a query response from an HBase query, which would give it to you in 50 milliseconds, you're probably now seeing anywhere between 54 milliseconds to 57 milliseconds. But does that really matter? And with all the cost benefits and with all the manageability and administration benefits that you get out of managed clusters, isn't that a good trade-off to take, right? So just to make it clear, you are not comparing exactly to the dot. You definitely have that lag, be it on the cloud, or be it within the same VNet, or be it in the same infrastructure as well. But the trade-offs are much more than what you want to pay for. Now, we've talked about the blob storage as well, so I just wanted to put forward, like, okay, what does this common storage do for us? So essentially, it just goes ahead and stores large number of blobs for us. It has certain capacity per storage account, and then you can associate multiple storage accounts to your Hadoop cluster so that you can increase that capacity. Usually, we see customers increasing the number of storage accounts for a particular Hadoop cluster, not because of the storage capacity, but because of the bottleneck with throughput capacity, if at all they run into that. Okay? Now, to overgrow even this principle, we recently announced another service called the Azure Data Lake. Now, what does the Azure Data Lake bring in? Well, brings in almost unlimited storage capacity. You can have petabyte file sizes bringing up on the Azure Data Lake. It's optimized for immensely massive throughput. You will never run into a bottleneck with the Azure Data Lake in terms of throughput. It's a high frequency, low latency, read immediately kind of an environment. And then you have durable and highly available storage capacity as well. Coming in from the AAD integration and deployment in minutes that run into this. Now, I talked about cluster optimizations, customizations. So these are the various options that we have for the cluster customizations that you can do. So you can go ahead and write a script action. You can have your own meta stores. You can have storage accounts and VNets. And then you have the possibilities of SDKs as well as IDE integrations. When I'm looking at managed clusters, the cluster integration options also span for you to benefit from. So you have Thrift, Uzi, Ambari, you have Templeton, all to take advantage of. And in addition to that, on the Microsoft's Azure, you actually have Visual Studio integration so that we make life easier for your developers to write code for your Hadoop clusters as well. Now, coming to the last point here and the last couple of slides, what would a cloud deployment for big data look like? From a query standpoint, you're ideally getting some data from websites via a mechanism to speed up things from ExpressRoute, storing it on a Blob store, and then bringing it onto a Hadoop cluster before performing any machine learning workloads on it. And then storing it back to a resilient storage like either an Azure SQL database or a document store like DocumentDB, or publishing it directly to the Power BI dashboards. Now you may ask, what happens when there is streaming? Well, here's the streaming workload. You go ahead and get your data via a cloud gateway onto a messaging queue. From a messaging queue, you get into a complex event processing engine, which can go ahead and connect directly to either machine learning or your Blob store, and then push it onto Hadoop. Now, those messaging queues could be open source messaging queues like Kafka and RabbitMQ, or it could be something that we have on the Azure first level services like Event Hubs. Again, the stream processing engine could be something like a Storm sitting on a HDN site cluster, or a first level service like Azure Stream Analytics. And in addition to that, you can also go ahead and orchestrate this entire data pipeline with the help of a tool called Azure Data Factory. So all of these are services that are added in and around all the open source goodness that we have on top of Azure. Now, this is just a glimpse of what we saw. I just wanted to give you a picture of the entire Microsoft Big Data solution as well. And if we look at all of these layers coming through, I have these products from data generation to event processing, to the storage capabilities, to the data processing capabilities. And the block that you see in blue over there is actually the open source Hadoop stack that we offer as part of the Azure cloud. And then there is the data usage capabilities in there as well. Of course, I talked about orchestration, and how could I leave that back? Now, just look at the way all of these are interconnected. You saw a simple diagram there. Just look at all the various kinds of connections that exist, be it from the traditional RDBMS onto the Hadoop stack, or extending the Hadoop stack with visualization tools, etc. And be it the batch mode of analysis, or be it the stream processing mode of analysis that comes together in red on this particular slide. You can ideally go ahead and cater to any kind of Hadoop workload today as a managed service on the cloud. And this is what I just wanted to talk about today. Just to go ahead and summarize the talk, we started with why, what, and how. The benefits of running Hadoop in the cloud, well, I just showed it to you that they far outrun any trade-offs that you may have. What do we do there? We have IaaS, PaaS, as well as hybrid offerings. Hadoop clusters in the cloud are absolutely fully managed for you. Let us do the dirty work. Let us wake up at 3 a.m. for you. Let us go ahead and fix those issues that you have with your job executions. You worry about the business logic that you need to implement and the value that you can add to that as a result of that implementation. Cluster customizations, well, we have a lot of our customers immensely well leveraging that. And then the architecture, well, it's the simplest deployment that you can have. If you're interested to learn more about this, just go to azure.com/hdinsight. If you have any questions in particular or feedback or follow-up questions from me, there's my email address as well. I have a few Azure passes with me, so if you have any of you are interested, just come over to me and I can hand those passes over to you as well. You can have a $100 increment on the trial that you have as part of Azure. Thank you so much for listening through this session. It was a pleasure being here and presenting for Hadoop on the cloud. Thank you, and have a great evening.